How does velocity squared impact kinetic energy in thermodynamics? Imagine you're riding a bike down a hill. The faster you go, the more energy you feel pushing against your legs. That feeling is connected to something called kinetic energy. Now, in thermodynamics, understanding how movement affects energy is super important. So, let's explore how the speed of particles or objects influences their energy, especially when their velocity changes. Kinetic energy depends on the square of velocity. This means if you double the speed of an object, its kinetic energy becomes 4 times larger. For example, if a ball is rolling at 10 meters per second, its kinetic energy is based on that speed. If it speeds up to 20 meters per second, the energy increases by a factor of 4. That's because the velocity is multiplied by itself, or squared, in the calculation. The formula for kinetic energy is 1/2 times the mass of the object times the velocity squared. So, if the mass stays the same, any change in velocity has a big impact on the energy. Doubling the velocity makes the kinetic energy 4 times bigger, while tripling it makes the energy 9 times larger. This quadratic relationship shows how sensitive energy is to changes in speed. In thermodynamics, particles like molecules in gases or liquids are always moving. Their velocities contribute to their kinetic energy, which affects properties like temperature and pressure. When particles move faster, their kinetic energy increases, raising the system's overall energy. That's why temperature is related to the average kinetic energy of particles. Understanding how velocity squared influences kinetic energy helps engineers design better systems. For example, when analyzing airflow over an airplane wing, knowing how changes in speed affect energy helps improve efficiency. Similarly, in water pipes, faster flow means more kinetic energy, which impacts how energy transfers within the system. So, in simple terms, when velocity increases, kinetic energy increases much faster because of the squared term. This means small changes in speed can lead to big differences in energy. Recognizing this helps us understand how energy moves and transforms in different systems, whether it's in engines, weather patterns, or even in tiny particles bouncing around in a gas.